problem 10.23, let f be a function n plus 1 times differentiable in an interval I, and let a and x be the 2 points in this interval. Assume that the integral defining this function Rn of x is 1 over n factorial times the integral between a and x of x minus t to the n f, the dn plus 1 derivative of t for n, all n, exists. Okay? Now first calculate R0s. Okay, R0 is 0 factorial is 1, so this is the integral between a and x of x minus t to the n of the first derivative of f okay, at t, so this is just f at x, right, minus f at a. Now integrating by parts, find the recurrence formula for Rn. Okay, so let's see. Let's see, u is x minus t to the n, and dv is going to be the n plus 1 derivative of t dt, right? Now du is n times x minus t to the n minus 1, and v is the nth derivative of t, right? Now this is x minus t to the n fn of t divided by n factorial minus, and then we have n divided by n factorial is 1 over n minus 1 factorial times the integral between, well, sorry, this is between x and a, and this is between x and a of let's see, it's x minus t to the n minus 1 f the nth derivative of t dt, but that this, all of this is Rn minus 1. Okay, and now this value when x is when t is x, this is 0, and when this is a, this is minus x minus a to the n over n factorial times the nth derivative of t. Okay, so let me write this here. Rn of x is minus x minus a to the n factorial, the nth derivative of t, minus is it minus Rn minus 1. Okay, is it correct? Yeah, no, sorry, so this is the derivative, the derivative with respect to t, right? So we have to, this is minus, so there's a plus here. Okay, plus. Okay, now having that, let's see, we have R0, solve the recurrence and interpret the result. Okay, so we have R0 is fx minus fa, right? So let me write it here. F at x minus f at a. Now we have R1 is minus x minus a divided by, so minus x minus a, minus x minus a times the derivative of f at t plus fx minus f at a. Okay, R2, let me write this in a different way. So this is f at x minus f at a minus x minus a f prime at t. R2 is going to be minus x minus a squared divided by 2, the second derivative at t, plus, and then we have plus f of x minus f at a minus x minus a f prime. Do you see where this is going? So you can keep doing this, but I assure you this is going to be f of x minus f at a minus x minus a f prime t minus x minus a squared 2, the second derivative t. Sorry, this is not t, this is a. Okay, I've been doing it wrong. Okay, this is at a at a, okay, now that's some point t at a, right, minus x minus a to the n divided by n factorial f the nth factorial at a, sorry, the nth derivative at a. Okay, now what is this? Well, this is the formula for the remainder, okay, the difference between f and the Taylor expansion of order n of f at a, right? So this is the remainder of the Taylor expansion of order n at x. So what this means is this formula is an alternative way to write the remainder using integrals.